Alright, so now I want to look at exploratory data analysis. The first part of the video, we look at how to prepare data for analysis. Right now, I want to explore our cleaned or prepared data. So exploratory data analysis is basically one of the techniques used in analyzing data sets to summarize their main characteristics, often with visual methods. There are two main techniques involved in the EDA. The first one is data summarization, and the other technique is data visualization. So we will be looking at the first part of it. So let me do this. So this is going to be EDA 1, which is data summarization. Yep. So shift enter. Then we can start with it. So with data summarization, we are just going to summarize our data set, right, which is basically a descriptive statistic technique. So to do this, we'll be looking at the we'll be looking at it for the quantitative variables. Then we also look at it for the qualitative variables, right? So there's going to be 2.1.1, which is basically going to be the data summarization, right, for the quantitative variables, right, or features. So let's change this to Markdown. Okay, so shift enter. So I want to start with data summarization for quantitative variables. So to start with, we are going to use our final data or our cleaned data, which is fdat. So we can look at it. Shift enter. So here we go. We have it. This is our prepared or clean data. Let's look at the info, the structure of the data set. So we have clean everything. Everything is now prepared and ready to be used for analysis. So let's describe it. So I want to start with um, the basic summary statistic. So we are going to use the describe function to basically get those values. So shift enter. And here we go. So we can see that for each of the variables, we are getting this basic summary statistic. We have the count, we have the mean, standard deviation, minimum value, 25th percentile or the first quartile, the 50th percentile or the median value, 75th percentile or the third quartile, and the maximum value, right? So this is for each of the variables, but we can see that it has ignored that of the qualitative or the categorical variable, right? So we will be looking at it very soon. So with this, but we know that we have the measurement we're taking for three different species, right? So let's look at how to get a summary statistic. All right, so I want to get a summary statistic for the measurement. Let's say I want to get a summary statistics for the variables, right, across the levels of species, right? So how do we do that? So we are going to use our final dot and say group, right? Group by, that is, we are interested in the categorical variable, which is species, right? And maybe we want to start with a count, so the function is count, right? So let's see, shift enter. So this gives us a count, right, for the variables across the levels of the species. We set those are vesicular and virginica, right? We can also look at the mean, right? Shift enter, and it gives us the mean for each of the levels of the species, right? So we can also look at that of this variance var, right? Can do the same for standard deviation, STD, right? So and let's say the quantiles. So quantile, right? And maybe we are interested in 25th percentile or the first quartile, the third, the median, or the median, or the 50th percentile, so 0.50, and the 75th percentile, the third quartile, right? So shift enter. So here we go. So this gives us the summary statistic, right? Quantile measurement for the variables across the levels of the species, right? So this is basically how to get the data summary for the quantitative variables. Now let's do that for the qualitative or the categorical type. So let me copy this and paste. So now I want to do data summarization for the qualitative, right? Qualitative variable, right? Which is the categorical type. So this should be 2.1.2. So let's say shift enter, right? Let me change this to markdown. Okay, so we now want to look at that for the qualitative. So how do we do that? And for qualitative variables, normally with the summary statistic, we can get it by making use of the um, using the concept of frequency distribution, right? So I want to assign my summary statistic for the categorical type to FD, which is the frequency distribution, right? So I'm going to use my final dot, right, and extract that of the species, and I want to get a value count, right? So FD to view the data set. So shift enter. So here we go. So this gives us a frequency distribution of the categorical type. So this is the species on the first column. The second column is given at the frequency. So for versicolor, we have it count, the number of versicolor, which is 50. Setosa, we have 49. Virginica, we have 49. Right. Now, with one thing that we also have to pay attention to is with the quantitative type. Sometimes your variables may be in different units of measurement. Fortunately for us, these were all measured in centimeters. But in reality, sometimes if you're dealing with some data set, they may not be in the same unit of measurement. This variable may be in, let's say, kilogram, this may be in dollars, centimeters, this may be in a different unit of measurement altogether. And for some algorithm, especially with machine learning, some of the algorithm that you're going to make use of requires that all these measurements or these variables or features are in the same, or they should be on the same scale of measurement, right? So how do we do that? In that case, we are supposed to pre-process or transform these variables by either standardization or normalization. That is, we have to standardize our data set or normalize our data set so that it can be on the same scale of measurement, right? So let's look at that quickly. So I want to add this to it. That is to transform, data transformation, or let's say I want to pre-process, data pre-process, pre-process. Yeah, so let's change this to markdown. Alright, shift enter. So this is very important, right? So for some, as I've already explained, for some algorithm or models that you're going to make use of, it requires that the unit of measurement for the variables are on the same scale. So in order to do this, we are supposed to either transform our data set by standardizing it or normalizing it. The main difference between the standardization and the normalization is that with the standardization, you always have your variables to the variables always have a mean of 0, right, and a standard deviation of 1. But with normalization, right, anytime you normalize your data, there is going to have a range of values between 0 and 1. Okay, so let me show you this. This is basically the formula for standardization. So we are going to compute the mean for each variable and subtract it um, from the data point and divide it by the standard deviation of that variable. But with normalization, we are going to compute the minimum value for the variable and subtract it right from the data point and divide it by the range of the value. That's the maximum of the variable and the minimum of the variable, which is basically going to give you the range. So this is how you can compute this manually to get a normalized data set, or you can compute this manually to get the standardized data set, right? But let's look at how we can do this in Python. So first of all, we have to install the scikit-learn library. This library has the function that it can help us to do or preprocess or transform our data set, right? So that it can be on the same scale of measurement. So you can install this by making use of the pip install scikit-learn, right? So if you have already installed this, then you can skip this line and just comment on it. I'm gonna comment on this and just import, right? Import scikit-learn, right? Or maybe you are interested in a specific function, which is the preprocessing. So I'm gonna say from sklearn, which is a short form of scikit-learn, want to import preprocessing, right? There's a function that we are interested in. Yep. So let's run this, shift enter. So if you have not installed this, then you have to basically run these lines, right? Make sure that it's on the first line. So you have to run all this line if you have not installed it. But if you have already installed this library, then you can skip these two lines, right? So yep. So once we are done with the importation of this, we can start with standardization. So standardization 1, right? So there are different ways to basically pre-process or transfer data sets. So we are looking at the first part of it. So let me say this std underscore dot 1, standardized data 1. So I'm going to use this pre-processing, right? So let's say I'm basically going to make use of the let's first of all get these variables. So let me copy this. Let's get our new data set. So new data set, new data set. So this new data set should only it should be made up of the quantitative variables, right? These ones. We are not interested in the categorical types. We want to extract this, and that. So I'm using ND for new data set. So for my final data, right, I'm going to use the ILOC function, which is basically the integer location based indexing, right, for selecting position. This will basically help us to specify the rows or columns based on their integer position values, right? So using this, what do we want to do? Square bracket instead. So this is for the row indexer and the column indexer, right? So for all the rows, we want to pick this variables. So if you check this, let me comment on this. If you check f that, dot info, right, you realize that this first variable separator length has been index 0. This has been index 1, 2, and 3. So we are interested in only this ones. We don't need a categorical type. So in order to extract that, I'm going to say I need index 0, 1, 2, and 3. Yep. So ND. Yep. So let me see head. So shift enter. So now we have extracted only that of the features, right? So this is basically what we want to work with. Suppose they are in different unit of measurement, we want to know how to pre-process or transform this so that it can be on the same scale of measurement by either standardizing our data set or normalizing it. So we're going to start with standardization. So standardization 1, we are going to use the pre-processing, right? So I want to say for my final data or my new data set, I'm going to pre-processing. I'm going to use a scale function, right? And I want to scale the new data set instead. Yep. So let's look at std1 dot 1. So let's run this, shift enter. So here we go. So we can see that the variables have been standardized, right? So this is just one aspect of it. Let me copy this. Another way to do this, to transform this data set, is to basically make use of another function known as the standard scalar function. So in this part, we want to basically say we want to from a scaling, right, from pre-processing, we want to import standard scalar, right, and want to assign standard scalar to SS. So I want to say standard scalar should be assigned to SS, right? So we are importing this as SS, standard scalar as SS, right? So I want to standardize our variables. So this is going to start, and I'm going to use standard scalar in this instance. So SS dot fit underscore transform. I want to transform our new data set or our features. So there's the function that you can use. So let's see this. Let's run everything, shift enter. So here we go, you can see this, right? It's similar to what we have here. If you scroll up, it's the same thing, right? So the last part or the last way to basically do this, let me copy this, shift paste what I have already copied. So for the last aspect of this, how to do the standardization, is to use the formula, this formula that we just looked at in the slide. So we can basically use this formula. So standardization 3. So I'm going to say now maybe I would like to look at the head at the end of the day. So let me clear this. So I'm going to use a formula. So for my new data set, there's going to be the numerator. So for my new data set, right, I want to get a mean of the variables. So dot mean and divide it by standard deviation. New data set std. Alright. So that's the formula I use. So we compute the mean, right, and divide by the standard deviation for each of the variables. So that's basically what you're trying to do. So let's run this, shift enter. So here we go. So we can say this, right, which is similar to what we have above. Right, so now if you look at the summary statistic for this standardized data, let's look at a summary statistic for the standardized data. So let's say, um, we have std, let me use the third one, std dot 3 dot describe. So shift enter. So you can see that anytime you standardize your variables, it will always have a mean of 0. This is approximately 0 and a standard deviation of 1, right? In other words, anytime you standardize your variable, it basically tells you the number of standard deviation each of the data point is going to fall below or above the mean value, right? So that's basically how to do this. Now let's move on to the normalization. So let me copy this. How to normalize our data. I'm going to use a standard scalar. So copy this. Paste. So normalization 1. Normalization 1. So from sklen preprocessing import, this time you want to make use of the minimum maximum scalar, right? So I want to assign minimum maximum scalar to right? So minimum maximum scalar, and change this to normalize norm that's 1. So change this to norm that's 1. Then from minimum maximum scalar, I want to transform our new data set, right, or only the features. So let's look at this, shift enter. So here we go, right? Another way to do this is to use the formula. So let me go up, scroll up, shift. So let's take this off. Let me scroll up and copy this. Oh, it seems it has moved a little bit much. I'm interested in this. Sorry, I'm interested in this one. Yep. So I want to copy this. Scroll down. Paste. Alright, so there's going to be normalization 2. Normalization 2. So this is going to 2. This should be norm and norm. Right, so now I'm going to use the minimum value, MIN, and this should be the range, right? So I'm going to use nd dot maximum minus nd dot minimum, right? So that's the formula that we're going to use. If you go back to this, you have to compute the minimum value for the variable, subtract it, right? Make sure that we subtract it from the data point that we have, and also compute the range. This is the range maximum of the variable minus the minimum of the variable, right? Or the data points. So that's basically what you're trying to do. So let's quickly run this, shift enter. So here we go. So if you look at this, let me close this. If you look at this, it's similar to what we have above here. Yeah, almost the same, right? So now let's look at the summary statistic. So summary statistic for the normalized data. Right, so I'm going to say norm that to describe, shift enter. So once you run this, you realize that for the normalized data, it's going to have a minimum of 0, maximum of 1, right? So this is basically about EDA 1, which is about summary statistics or data summarization. So in our next video tutorial, we'll be looking at EDA 2, which is about data visualization. I hope you stick and stay.